Hi everyone, in this video we continue our lesson on coterminal and related angles. And in the first problem we're told, given an angle theta lies in quadrant 2 and cosine of theta is equal to -3/5, find the exact values of sine of theta and tangent of theta. So here let's think about this. Our angle lies in quadrant 2. So what does that look like if I draw this on this circle here? Okay, so it's in quadrant 2, which is this quadrant here. Cosine is negative, so it's -3/5. Okay, so that would mean that the ratio of the hypotenuse to our x value is the magnitude is 3/5. So that means that if I make this distance 5, then my x value is -3. And my y value is unknown, but I can solve for my y value. So I know that using the Pythagorean Theorem, y squared is going to be equal to r squared minus x squared. And since this is in the second quadrant, y is going to be positive, so y is going to be equal to the positive root of r squared minus x squared, because this is a right angle triangle. So y is going to be equivalent to r is 5, so we have 5 squared minus 3 squared, all square rooted, which is equal to positive 4. Now, if this were in either quadrant 3 or quadrant 4, then our y value would be negative, and we would have had to have taken the negative root. So y is equal to 4, and we have -3, 4. So that means that the sine of theta is equal to 4/5, because it's the y value divided by the radius. Tangent of theta is equal to the y value, which is 4, divided by the x value, which is -3, which simplifies to -4/3. In the next problem, we're told determine the exact primary trig ratios for angle Q being equal to -150. So let's just go ahead and we'll clear that circle, and we'll try to sketch this out. So for an angle of -150, we have to draw the terminal arm and the initial arm in standard, or it's to have this in standard position, we need the terminal arm along the initial arm along the x-axis rather. And this angle will be drawn like such. So this angle is, this is -150. Hang on a second. Since the angle is negative, I'm actually going in the other direction. So I'm going to draw the terminal arm and rotate it 150 degrees clockwise. So be really careful, because I almost missed that. It was -150 degrees. So that means that this angle is -150 degrees. And let's think about the reference angle here, and since it says determine the exact primary trig ratios, that's kind of an indicator that the reference angle is going to be an angle in a special triangle. And that's exactly what happens. If you do 180 minus 150, then you get 30 degrees, and that's this the reference angle is 30 degrees. So that's a 90-degree angle, and this is 60, so it's a 30, 60, 90 triangle. So what that means is that the cosine ratio of 30 degrees, and remember the 30, 60, 90 triangle has side lengths in the ratio of, if this is 30 degrees, then this is 1 to √3 to 2, and this is 90, and this would be 60. So the cosine of 30 degrees is equal to √3 over 2. But we don't want the cosine of 30 degrees here. We want the cosine of -150. So since the x value here the ratio of the x value divided by the radius, our x value is going to be negative in this quadrant. The ratio of the x value divided by the radius is going to be minus 3 over 2. So that means that the cosine of negative 150, let me rewrite this. The cosine of negative 150 degrees, units are important, is equivalent to minus cosine of 30 degrees, which is equivalent to minus root 3 over 2. We don't really need to write minus cosine of 30. As long as I know what my x value is, then what the ratio of the x value is to the radius, I don't need to show it in terms of the reference angle. It's just sometimes it helps to think about it in terms of the reference angle. Next, we have to figure out what the sine ratio is. So the sine of theta, the sine of 30 degrees is equivalent to the 1 over 2, because we have in this triangle, we have that the sine of 30 is the opposite divided by the hypotenuse, but in this triangle we have that it's the y value divided by the hypotenuse. Now the y value in the third quadrant is negative, so that means that the ratio is going to be negative, but it's going to be the same as in the 30, 60, 90 triangle, just with a negative sign. So the sine of the sine of not theta, the sine of minus 150 degrees is going to be equivalent to minus 1/2. And lastly, the tangent of minus 150 degrees in the third quadrant, the tangent, remember the cast rule? In the third quadrant, the tangent is positive. So we know that we're going to have a positive ratio, and it's the ratio of the opposite side divided by the hypotenuse in this triangle. And so it's the y value divided by the x value. The y value is negative, the x value is negative, so the tangent is going to be positive, and we'll have that it's equivalent to 1 over root 3, because the x value is well, we don't actually know what the x value, we don't for sure know what the x value is, because this is just, we're not told what the radius of the circle is. But suppose this were a unit circle, this would be root 3 over 2 and comma 1/2, and this is negative root 3 over 2 negative 1/2, sorry. And I got those values just by looking at what the distances are and what the ratios of the distances are in the 30, 60, 90 triangle. And that's only if this is a unit circle. So if that's 1 unit, and then minus 1 and minus 1, then these coordinates would be negative root 3 over 2 and minus 1/2. Sometimes it helps to just say that the radius of this circle is 1. That's why we use the unit circle. Just simplifies the problem. Okay, so tan of negative 150 is equivalent to, it's going to be equivalent to 1 over root 3, which we have to rationalize. This is equal to root 3 over 3. Okay, moving forward, it says, without using a calculator, determine two angles between 0 and 360 that have a cosine of minus 3/2. Okay, so cosine is negative in which quadrant? So it has a cosine ratio. I should have said it has a cosine ratio of minus 3/2. So if you think about this angle here, where if the cosine ratio is minus 3/2, let's think about this in terms of the example that we had above. Because in the example above, the cosine ratio was minus 3/2, but the angle was minus 150 degrees. So that's not between 0 and 360. So, but I mean, the problem is kind of already illustrated for us here. So here we had that if we have an angle that's not 150 degrees, but we have an angle that is rather, we have a positive coterminal angle, or the principal angle in this case. This angle here is, let's see, it's 180 and it's 30 degrees past this, so that's positive 210 degrees. Well, 210 degrees has a cosine ratio of -3/2. Okay, so let's say that if cosine is equal to -3/2, then theta could be equal to, whoops, that's a very bad theta. Then theta could be equal to 210 degrees. That's one possibility. Now, think about the cast rule. The cosine ratio is negative in quadrant 2 and quadrant 3, and we figured out this angle in quadrant 3. But we also have the reference angle. We have the cosine ratio being equal to -3/2 for a reference angle of 30 degrees in the, let me erase this a little bit, in the second quadrant as well. So if this is 90, well, this would be 30 degrees. This would be 60. And this x value is -3/2 here. And the y value is -1/2. And this angle, this green angle here, would be 30 degrees away from, it's 30 degrees away from 180, so it is 150 degrees. So that means that theta could be equal to 210, or theta, or I guess, and theta could be equal to 150 degrees. So both of these values for theta satisfy this equation. You can go ahead and try this out, and they're both between 0 and 360 degrees as well. But if you plug cosine of 210 into your calculator and cosine of 150 into your calculator, as long as your calculator's in degree mode, you should get the same value for the cosine ratio. Okay, so next it says solve sine of theta being equal to -0.983. And to do so, we are going to need a calculator. Oh, and it says that the angle is between 0 and 360 degrees. Okay. So let's go ahead and we'll erase what I've written on the circle up here. Because we might use this again. One of the things to note is that the sine ratio is only negative in which quadrants? Let's see. Using the cast rule, the sine ratio, so CAST, the sine ratio is negative in quadrant 3 and in quadrant 4. So we know that the angle is either in quadrant 3 or quadrant 4. Now, on my calculator, what I'm going to do is I'm going to try to solve for theta using the arcsine function, or the inverse sine function on my calculator. So I'm going to say that theta on my calculator is equal to the inverse sine of -0.983. And based on how arcsine is defined in our calculators, arcsine is only going to spit out one value, we hope. So press arcsine of -0.983. And you should get -79 degrees if your calculator is in degree mode, which I hope it is. So -79 degrees to the nearest degree. Now, where is -79 degrees? Well, if we draw an angle in standard position, -79 degrees is this angle. Okay. Whoops, it's actually bigger than that. It's not even, wow, I wasn't even close. Okay, so minus 79 degrees is more like this. There we go. So, but in this problem, we are told that theta is between 0 and 360. So one solution that's between 0 and 360 is the principal angle for an angle that's coterminal to this one. So I can do, if I draw the angle from the initial arm, if I draw the angle like this, this angle would be, it would be 301 degrees. So that means that one solution is theta is equal to 301 degrees. Oh, whoops, sorry, this is not 301 degrees. What am I doing? Wow. Because it's 360 minus 79, which is 281 degrees. So sorry, this should be 281. This is 281 degrees. That's one possible solution. The other possible case is that this angle could, the angle could be in the third quadrant. So we could have our angle in quadrant 3. And the reference angle would be 79 degrees. So that would mean that this angle here would be 79 degrees. And then in this case, we're 79 degrees past, we're 79 degrees past 180. So if you add 180 plus 79 degrees, that'll give you this angle right here. So 79 plus 180 gives you the other value for theta. So theta is equal to 259 degrees. So you've got theta being equal to 281 degrees, which is one solution, and theta being equal to 259 degrees, which is the other solution. And you can see that because sine of theta is negative in two of these quadrants, that's why we get two solutions to this equation. And if we were to say that the sine of theta could be equal to negative 0.983 for any value of theta, then there would actually be infinitely many solutions to this equation, and which is kind of interesting. And you'll look at those solutions, how to represent them in terms of integers later on in your math career, probably.